Hey-yo, we got Vikram joining us. So, what's up, dude?
Hey Demetrius, good to see you again.
You weren't ready for that intro on there.
I
You
loved
weren't
it,
expecting cows, were you?
but I loved it. It's the only way.
Oh man. Dude, so it's been a while since we chatted. I love what you all are doing at Galileo, and we're going to give a huge shout out to Galileo. If anyone wants to try it, we're going to drop all kinds of links. You're going to show us all about what you all have been working on. And I got to say, thank you so much because you all decided to sponsor this event, and that is huge. It means a ton. It keeps us in business. It means that I can do these things and I can dedicate more time to it. So thank you so much, Vikram.
Thank you so much. And there are Galileo socks as well.
Oh shit, no way. All right, I didn't realize that. I'm going to be giving them away then. Anybody in the chat? Let's oh my god. Lou just wrote in the chat that last video was moving, and that is how you get yourself some Galileo socks. All right. Let's do it. So, Vikram, I'm going to share your screen right now,
Sounds good.
and yeah, man, jump into it. I'll see you in like 25 minutes. And for anyone that is watching along, feel free to ask questions in the chat and we'll get to them at the end.
Sounds good. Thanks, Demetrius. Yeah, and I'll try keeping about 5 minutes in the end for any questions. Just a quick introduction about me. So I'm the co-founder, CEO of Galileo. The company itself and the product is completely geared towards your data and how you can figure out what the right data is to work with. I just heard about, just before this, we were talking about the terrible experience debugging, and whether you're working with recommendation systems or whether you're working with NLP models or now with LLMs. But the whole reason we started the company was because before starting Galileo, I was heading up the product management team at Google AI. And while building out models there, we faced this problem on a daily basis, like literally days and days of just working with Excel sheets and Python scripts to debug the model and figure out where the failure points reside. We used to call this data detective work. So a lot of scars from that. And that's kind of what I also wanted to talk about over here with all the chatter about LLMs now, which is to what Alex was mentioning before. It seems like this is the new phrase that we've all anchored around, and it used to be foundation models just like literally a second ago, and transfer learning based transformers before that. So it's interesting how fast the entire industry is moving. But what's interesting also is that the first principles still stay true, and that's what I wanted to discuss. The first principles are that ever since machine learning ever came about, for those of us like me who've been in this space for the last decade and more, it's always been about the data, right? That doesn't change. But what I think changes is what does that mean in the context of LLMs, in the context of generative AI, for people who are trying to work with GPT or any of the other wonderful open source models that are out there. So obviously, unless someone's living under a rock, we all know that AI in general is having quite the mainstream moment right now, powered by this huge leap in model development, essentially, like just being able to train models on a lot more data, huge corpus, like a lot of other pieces here that have come in into making this happen today. But almost every day you see things like, Y Combinator having a good almost more than 1/3 of their entire class or 1/4 of their class being generative AI apps. We're seeing this with other accelerators as well. Hearing about how this could be transformative for the enterprise. We're also starting to see a lot of worry and trepidation in the market. And how do you navigate generative AI for customer service? Is it a bubble? There are think tanks talking about this. It's overall just a really interesting time in space. And the interesting thing is that all of these different kinds of headlines have come in just in the last 3 or 4 months, right? Like rewind to December, and a lot of this wasn't even in the zeitgeist, which is ridiculous. So of course, like we are all having this huge moment now where AI has gone mainstream, and everyone in the street just kind of knows about GPT, and it's kind of brought it out there. However, I think the piece which I wanted to really flag is that it's for those of us who've been in the industry for a long time, which it seems from the chat and all the other talks that I've seen so far, it's a lot of us. So we kind of know that we've seen this movie play out before. It's just now there's so much more hype, and someone's done their marketing game really well because everyone's talking about it. But essentially, if you rewind all the way back to 2012-ish, it was, I think, it was 30th September 2012, and there's this CNN called AlexNet, which came out and won this ImageNet challenge. And people were talking a lot about that, and there was this article in the Economist at the time, which in my head is kind of when you're reaching mainstream, where they talked about how suddenly people started to pay attention, not just within the small AI community, but across the technology industry as a whole, about what's going on here. How can you classify these images in such an interesting way? This is going to be a huge breakthrough. And that was, of course, on the heels of a lot of interesting developments in the GPU space and from compute and storage, etc. But all of that's what led to that happening at that point in time. You fast forward from there just a couple of more years, and you get to the huge transformer paper, like Attention Is All You Need, which came out of a sister team of mine at Google. And this was huge, right? And just that's what led to our teams at Google creating BERT. And then because BERT was open source and anybody could build on top of that, it led to increasingly these models becoming commoditized entities. And we saw this huge explosion in terms of DistilBERT coming about, Roberta coming about, SpanBERT, and so many others. And we saw companies like PayPal coming up with what they call PayPal BERT. If someone's thinking about GPT, what's called Bloom GPT, it's very similar, right? Like PayPal basically said, BERT is great, but it's trained on the entire Wikipedia corpus, not good enough for us. We're going to fine tune this and train this on specifically PayPal's data. And that's what we need for our use cases to actually work out. So awesome. I'm going to pick up BERT just off the shelf. It's super commoditized, but I'm going to fine tune that on this specific data that I have. And that's going to work for me and my models and my users and my use cases. Similarly, stock news sentiment analysis with FinBERT came about. So this whole entire explosion of models essentially led to the commoditization of these models as entities. And so my team at Google essentially was also just picking up BERT off the shelf, and that was the job done. We would experiment with maybe a couple of variations of BERT, but for the most part, it was, again, what we called data detective work, where we would figure out what's the right data for us to train with. Once the model is in production, you have to, again, kind of check for whether there are any data failure points for the model, et cetera, et cetera. So it always comes down to that first principles. And that's what happened there in, this is, I think, back in 2017 to 2020, 2021. So that was, like, in my head, the first wave of large language models, because back in 2018, I guess, like, BERT was a very large language model. So I guess now we're dealing with larger language models, and that's the only difference. And because of that, it's much more powerful. And because of that, the stakes in terms of what can go wrong are also much, much higher, right? So that's why we have to be very careful. But right after this, we started to see this huge wave of what data scientists kind of already knew and were talking about. But I think Andrew Ng coined this really interesting phrase of data-centric AI, where it was interesting because when we talked to more and more data scientists, they started to really gravitate towards this phrase, because they realized that already that when they were working with their models, those had become commoditized, and good quality data and knowing what data to train with, not quantities of data, became the barrier as well as the moat. Because some companies just did not have enough data. What do you do there? Some companies that did have proprietary data, that just becomes the moat for their business. It becomes a massive differentiator for themselves. So the whole industry started gravitating towards this idea that, great, these models are commoditized. Now I'm going to start to focus more on the data flywheel that I can create here. And if I don't have enough data, can I synthetically generate some of this data? Can I spend a lot of money on labeling the data? Can I, what do I do after that when the labels are incorrect? How do I fix it? All of this started to come under this umbrella of data-centric AI, which Andrew Ng coined a couple of years ago. And this has also essentially been at the heart of what Galileo does. It's essentially a very data-centric platform for being able to build great machine learning models across the ML workflow, whether you're starting from before you even label your data, right after you're label them, and you're training and iterating on it over and over again. We're in cahoots with the model, and we tell you, the Galileo product automatically tells you what the model failure points are. So you're not spending weeks and weeks in data detective work. That's the enemy for us. And then once your model's in production, again, like telling you what's the right data to train with next, and pick up next. So very much in line with this entire movement. However, back to the present again, what we're seeing now is a new wave of models that are emerging. Super exciting times, of course. Like, I think all of us are feeling that, and we've again increasingly seeing at a much faster pace than what we saw in the last iteration of this a couple of years ago, that the models are becoming commoditized way faster, right? And GPT, it feels like, just came about a little while ago, and then Llama came about. Google has its own many applications built on top of that to further market these different models, and then a whole host of different open source models coming up right on top of that. But with this commoditization, essentially, what we've started to see is this is going mainstream again. And so, again, in The Economist, about 10 years later, after this first quote that came up in 2012, again, there was this quote about how foundation models can do these magical things, and that there's huge breakthroughs. And this was in June 2022. So The Economist had not got on this new wave of it being called large language models yet, but they were calling it foundation models, similar to what Alex was mentioning before, where you can call it either, but I feel like it's good for the industry to gravitate towards one term. But essentially, at the heart, they're kind of the same. They are the basis of what you can build on top of. So it's really interesting how we've gone through this cyclical process. In the first iteration, where an interesting ML breakthrough happens, people talk about it. It gets a lot of attention, gets into the mainstream, and then gets commoditized very quickly. And then again, now we're getting into this phase where people are realizing that, wait, these models are great. A lot of them are closed source. So now, how do I use this for myself? And how do I figure out what to train my models with? So a lot of these different kinds of open source models have been coming about recently, and some of this has been mentioned in a few talks before. But it's interesting how you have Databricks coming up with Dolly, for instance. You have Alpaca, who's come out of Stanford. Just super interesting to see, where they've basically been trained with much lesser amounts of data, much smaller amounts of money as well, but basically like fine-tuning the larger model based off of data that's coming from a large language model. Bloomberg GPT, again, very similar to a couple of years ago, PayPal BERT came about, and now you have Bloomberg GPT coming about, where they've trained it on their own financial data. The model itself has a lot to be desired, and this is just the beginning, I'm sure, Rev 1. And after this, they're just going to keep iterating on it over and over again with better data and making sure that the prompts are better as well. Another example which I came across was Eigel, which is an instruction-tuned German LLM family. So it's interesting how every single use case there, if folks are trying to find data so that they can train open source models with and just hone this for themselves. And there's going to be another proliferation very similar to what we saw with the BERT era of doing things. We're seeing that again with the GPT era of doing things. And the difference is the BERT era started with open source for the most part, versus now we're seeing this go from have a bifurcation between the closed source APIs versus the open source. And both of that, I feel like it's a healthy competition and healthy thing to happen in the market. But there's just going to be this huge proliferation of open source models, and because of that, a lot of customers and companies, especially in the enterprise, trying to curate their own models for themselves so that they can have a differentiation and have that moat be built out. Again, what we're noticing here is yet again that good quality data is emerging as the big blocker and the big moat for the industry. This is by Greg Brockman. This is an interesting quote which really hit home for me. This is for those who don't know, is the CTO of OpenAI. He was a co-founder of OpenAI, and he was the CTO of Stripe before. And in fact, not unfamiliar at all with this problem. And we've been mentioning this before about how 80 to 90% of what a data scientist does today is basically just staring at the data, trying to figure things out, trying to fix it, and then iterate on it over and over again, right? Across the entire ML workflow. It doesn't matter if you're just starting out, you start out with a whole corpus of data, or if you're just iterating on the training cycles, or if you're on the model production side of things, you're just constantly iterating with data. And it's a from a lot of our customers and partners today at Galileo, we've heard of this being referred to as the most soul-sucking part of the job, but yet the most critical and mandatory part of the job. And this whole notion that this is the manual inspection of data has got to be have the highest value to prestige ratio of any of the other activities is true. It's a really, really hard problem to solve, and it's typically very, very manual, which is exactly what we're in at Galileo trying to flip the narrative of. It doesn't have to be manual. We can automate a lot of this. We can make this much, much easier. And the same thing, the same principles hold true even today. So the other piece here is that when you're building LLMs, data becomes extremely critical. And I think more and more people who are in the weeds of building out ML apps using, whether it's the predictive models or generative models, what have you, you very quickly realize that the data is the very important piece. And now with these generative models, which I guess what you're calling LLMs, it becomes important for a couple of reasons. So I'll maybe touch upon that first, like why it becomes really important, and then I'll talk about which aspects of the entire flow when you're creating these apps are where you should be where we should all as a community really be thinking more about how we can invest in, where research needs to can be pushing the envelope on, and where tools can be built out to actually help out developers and really turbocharging their workflows and giving them superpowers. So the first part is why this is really important. So as we all know that model hallucination is a very real thing. We actually saw that in the I noticed that in the prompt injection piece that we were doing, where very quickly we were running into these model hallucinations, and that happens all the time. It reminds me of these of how fake news starts to spread across social media. You just don't know what to believe anymore, and so the model is kind of similar. It's like I don't know. Here's an answer, and it's very confident about the answer, but how do you know whether to believe in that or not? But with the right kind of data, with the right kind of prompting, the hallucinations can reduce. It's just a matter of being very, very cognizant about that. So that's just really important. Obviously the super popular story about the case study around this is Google's AI chatbot Bard that made that factual error in its first ever demo. There have been tweets by Sam Altman and others about ChatGPT as well, where it's like, do not believe necessarily in everything it says. Google Bing in its new release for its chatbot also said that take these results with a grain of salt. So it started to the mitigations around hallucination have started to emerge in legal text in these applications. But as app builders ourselves, we can fix this by trying to be better about the inputs that are going into the LLM itself, which I'll talk about just after this. The other piece is, becomes very critical when you're fine-tuning your LLMs to your use cases. Again, the Stanford Alpaca was a great example of this. We've seen a whole host of these, to be honest. Koala came out of Berkeley recently. It's a really interesting paper. If you've not read it, it's about a dialogue model for academic research, specifically trained, I believe, on just a bunch of academic research papers. There's a Portuguese fine-tuned instruction version of Llama. There's a Chinese instruction following a version of that as well. So there's the power of just providing a model out there so that you can fine-tune it is exactly this. It leads to a huge explosion of very individualized kind of models for anybody else to use in the world. And that's where innovation can begin. And now you can start to focus on your data on top of that. So you can fine-tune your LLMs. And all of these folks basically had some level of some corpus of data which they could fine-tune their model on top of. The third reason is to ensure the model responses are predictable and of the highest quality. Because at the end of the day, especially when it comes to enterprise use cases, what we keep hearing from our from customers at Galileo and our partners is that I can't launch a model unless I have trust in it. And this whole notion of the what is it, 10 or 20% of models reach model production, it's not really about the lack of tooling in the way. In fact, I would argue there's too much tooling along the way to build great models. It's more about how do you make sure that the model is of a very high performance. And that's the biggest bottleneck. How do you get there? And again, for that, data has become the biggest bottleneck to get the model to that high performance where a data science team can feel like I can truly put this out there in production. And then once it's out there in production, can make sure that I have the wherewithal to be able to make sure that's always performing really well. There are a couple of things in which we can do to be better when it comes to doing more data-centric LLM development. Going back to Andrew Ng's coinage of this term, data-centric, applying that here to LLMs, there are many different ways to do this. The way we've been thinking about this at Galileo has been that it always comes down to the inputs, right? And earlier, when you think of foundation models or transformers, the inputs used to be the model, the code, and the data. And what we noticed was the code was minimal, the model was commoditized, the data becomes the 100,000-pound gorilla in the room that you have to fix. Right now, what you're noticing is it's similar. The model is commoditized, the code is minimal, but the big inputs now are the data, but also the prompts, right? And so my argument here has always been that we need to figure out how to balance between both. You do need to fine tune your models with a lot of data, but again, like that can be difficult because a lot of the practical reality is sometimes you just don't have enough data. And sometimes if you have a lot of data, you don't know whether it's of high quality or not. So you can also just use prompting, but to be able to go the extra mile and be able to make sure that the model output is good. It depends on the use cases that you're working with. However, it's really important to make sure that you're taking control of your inputs. And what I mean by that is when you think of prompts itself, right, it's very critical to optimize for a few things and keep that top of mind. One is the structure of the prompt itself, right? So something which is really popular these days is just zero-shot prompting and prompting the model that way. But there's a whole host of research that's being done around how we can be better about the structure of the prompts itself. And I think this is somewhere where a lot of the premier research labs that we talk to, and half of our team at Galileo is ML research that's constantly pushing the envelope on exactly this kind of stuff. We keep thinking about this, like what can we do which is better? And one paper which we read recently, which is really, really interesting, which came out of my previous sister team at Google Brain, was this idea of chain of thought prompting, which essentially it's a very simple concept. It just means that instead of just saying that in your prompt template input, instead of saying the example answer for a question like this, where you're doing almost a math calculation and saying, hey, the answer is 11. Instead of that, if you just reframe the answer to actually tell the model the chain of thought that you used to come to the answer, the model outputs can be much, much better. So that's a slightly different structure towards your prompts. And it's a really interesting paper where they tested this out against a whole host of very large language models, and they noticed that as compared to standard prompting, by an order of magnitude, it does much, much better. So this is an example of where I would urge all of us to be a bit more cognizant about the structure that we're using in the prompts itself, and look out for better research and maybe share across the community what the right kind of structures are for these prompts, so that we can all benefit from it holistically. The other piece is context and retrieval, of course. The more context you can give the model, the better. More examples you can give it, the more retrieval you can get, the better it is. Pinecone is an example. This is certainly not the official logo of Pinecone, but those who use retrieval mechanisms for their during prompting will know that it really helps in augmenting the outputs of the model. But again, the question there becomes when you are using a vector database or some kind of a repo of data for your examples and giving context to the model, the question becomes, is that the right kind of context? If you're using a vector database, the question becomes, is there other kind of context that you could use which is maybe similar, or close by in the embedding space that you could pick up. How can you be better about that? So that kind of being better about the context that you're providing and tweaking that, and maybe even fine-tuning that over the course of many different prompts is super critical. And the third one is just instruction for these prompts, and just being able to give the right kind of examples and tweak that over and over again is super critical. So there's a lot there in just prompts itself, which is why perhaps there's this new term around prompt engineering that's coming about. But the whole reason for that is because there's a lot here in terms of what you could do for improving the output of the models and making that a little bit more predictable before you put it out there in the wild. Apart from that, you can, of course, just fine-tune with label data. And while doing this, it's, number one, extremely expensive for the most part to use a labeling tool, and also very time-intensive sometimes. But at the same time, it's extremely critical here when you're fine-tuning to identify whether you're seeing any performance regressions caused by the fine-tuning of the model. And especially now with LLMs, right, this is much more exacerbated because these models have been trained with so much data, and the corpus of data is so much larger that when you fine tune it with certain kind of data, the model performance that you see, it is not going to be that great. So you have to keep doing it over and over again to be able to get to the point where you can have a model that works really well for your use case, whether it's finance or the contact center or what have you. The second piece is, of course, incorrect ground truth. No matter what products you use, no matter if you have in-house labelers, if you have humans in the loop, if you're doing reinforcement learning, if you're doing RLHF, there will always be incorrect ground truth information. And this becomes a hair on fire issue. How can you automate this? Are there ways to do that? How can you get faster about figuring out what the incorrect ground truth is? A lot of this is very similar, again, to what used to happen in the world of transformers and still does for predictive ML. And those same principles and first principles still apply. And the last piece is maintaining data freshness and repeated fine-tuning. Because again, the models in production, that's not the end of the day. Like, you're not done and dusted. You can't just move on to the next thing. You have to keep monitoring it. You have to keep figuring out whether you need to fine-tune again. What's the right data to fine-tune it with? That's, again, something which exists today with the world of foundation models as well, and with transformer models. But it is, again, super important as we're building LLM apps across the enterprise. And there's a whole lot more of things that you have to do on the fine-tuning side too. So TLDR here is when you think about being data-centric, so to speak, in the world of LLMs, it's not just the fine-tuning of your actual label data, but also looking at the prompts and analyzing that from multiple angles and making sure that you're good on both fronts. So I know I'm at time, maybe even beyond. Sorry, Dimitrios, if I am, but essentially LLMs, we all know, are ushering this new wave of baseline open source and closed source models, and the enterprise is benefiting from this. We all are. So very exciting times. So I would say, like, we should just get our data ready and have our first principles hat on, and get to make sure that we are optimizing the different prompts that we're using, as well as the data that we're constantly fine-tuning it with. So I'll stop here, Dimitrios. I don't know if there are questions at all, but I'm happy to take any.
There were a few questions that came through. Let me find them real fast because I thought it was really nice. So let us see. There was one that I wanted to find, and now I can't find it. Of course.
I'm also available on Slack, by the way. So if anybody has any other questions, feel free to reach out to me there too.
There we go. So we can continue this conversation in the community conferences channel, but I think there was where there were some really good ones, and of course in the chat itself I struggle. So in the meanwhile, if anyone has any questions, throw them in, because there was so we had some people singing the praises of Galileo. Then they have, there was one person talking about how when they did fine-tuning of BERT in the past and then they saw the results, they never thought we would get to this stage that we're at right now. So, oh man, there was a good one, but now I can't find it. Okay. Anyway, for those people who have questions, go into Slack.
Yes, please.
Because I guess we're not going to get it here. I've failed you as the moderator. I had one job, man. I had one job, and then
No worries.
you can
Demetrius.
see how good of a moderator I've been.
I mean,
Okay, we got one coming through. Now that it's been a minute. Have you seen regression in prompt performance when updating models? How do you manage that?
You do, and it's a lot of experimentation, to be honest, right? Because you're constantly changing the kind of models you're using. You have to test and evaluate those prompts. I think the way to manage this again gets back to first principles. You have to have the right kind of metrics at your disposal. You have to have the right kind of tools to be able to check for, which model did I use here? What was the response from the prompt for what input? And then be able to make decisions around that. And that is something that we've been hearing again and again from industry practitioners, that it's been really hard for them to manage. This entire the comparison between how you look at different prompts, because it gets into the hundreds very quickly, and then the thousands, and then you have multiple prompts, multiple models.
Totally.
The matrix is just huge, and so it is partly a software engineering challenge, I think, which is exciting for the MLOps community. But I also think it's a little bit of a ML research challenge, and that's why we keep talking to the research community, because we need better metrics, in my opinion, to evaluate the prompts from a model perspective, to know which one is doing well and which one is not. And honestly, right now, I've been asking the different research agencies, my teams at Google before, and there is very little out there right now in terms of what metrics you can use to evaluate these prompts across the board. So people are kind of defaulting to the usual blue scores and other things like that. But I think something new needs to come about and help there. But for now, software engineering tools are the best bet.
Dude, well, the big question that I have is, do you feel like prompting is the end state? Like, are we not going to just move past prompting eventually?
Move past it? There's a big debate there, Demetrius. I think you open up a can of worms that they'll literally, amongst the people that we talk to, there's two different camps. There's some people who say that that's all you need. You don't need to fine tune the models anymore. That the models have arrived. Throw any data into this. We just need to do inference with prompts. Some folks say prompts are stupid. You just have to always fine tune your model. I believe the reality of today is that you need to do a bit of both. It depends on your use case. If you're building a very high intensity app, where the downside of getting something wrong is really high, you need to do a lot of fine tuning to make sure that you can get to the 99th percentile or the 95th percentile. But I think the here and now is prompting is very, very important. It is a real part of the workflow, so we can't ignore it. But I do think it's going to stay for at least a while, until models just get that good, which is probably going to happen. But again, the market is changing so fast, we have to kind of index on the here and now. And I think at least for the next 1 to 2 years, it's going to be a thing, but it's just going to get better and better, and tools are going to get better and better for helping people do prompting faster, and maybe it'll be automatic at some point. Here's the prompt you should use.